Hey everybody, this is Alex Merced from alexmercedcoder.com. And this is going to be day 5 of my 100 Days of Go and Rust video series. Okay, so, again, the idea behind here is over the 100 days to get comfortable with writing Go and Rust, particularly with the standard library. So I'm not going to, maybe later on we get into like frameworks and whatnot. But really I just want to kind of, and this is personally for myself as well, to just get much more comfortable with just sort of the basic syntax and ideas of these languages. While I have some familiarity with them, they're not as necessarily like as much of a muscle as like Python, Ruby, and JavaScript are, where like I could pretty much work my way through those other languages fairly comfortably without much thought, while, oftentimes I find myself doing more troubleshooting with Go and Rust still, although definitely more comfortable than I was, let's say, years ago when I first started dabbling. But I don't dabble as much as I do with, again, Python, Ruby, PHP, etc. So I figured, let's do the whole 100 days thing and and make a video for each day for that exercise. Okay, so that's, but I'm assuming if you're watching video number 5, you kind of know this already. But in this video, what I want to do is strings. And just again, we've kind of talked about strings a few times in the last previous videos, but there's just certain string operations which are sort of like important to kind of be aware of how you could do them and what the mechanics are for doing them in whatever language. So this is things like splitting a string, reversing a string, I think, and how to join the string back together are fairly important operations. There's plenty of things like, also that you could think of, like how could I use regex with a string, whatnot. I'm not going to go do every possible thing with a string. Main thing what I like to do is talk about like splitting, joining, and reversing. Okay, because there's a few things you'll learn along the way when we do those. Okay, so first we'll do it in Go. So I'm going to head over to Go. Okay, let me just clean this script up for a little bit. Okay, now the thing you got to be careful for in Go is that if we don't use a library, we will get an error. So if I import something that I don't use, I will get an error. So I'll remember that before we compile. So first things first, I want to remember how to split a string in Go. Okay, so in JavaScript, I would use like the split method, and I can split it based on string. Now, how would I do this in Go? So let's look it up. Again, these videos are not as much me teaching as me learning and you watching me learn. Okay, like that's the idea here. This is like me learning Go and Rust over 100 days. Okay, so string reversal. Actually, no, not string reverse yet. For string split Go. 3 ways to split a string into a slice. Okay, and I haven't talked about slices yet in Go, but what a slice is essentially works like an array, but it's not an array. It's really what you're doing is you're working with like a slice of a larger array, and because you're dealing with a subsection of a larger array, you can then add to it and manipulate it a little bit more, because what it does, it allocates more memory than what you have in the array currently. It always kind of keeps some extra spots. Allowing it to have that sort of dynamic feel of an array, kind of like you would, or like a Python list or a JavaScript array that's a little bit more dynamic. Okay, so first let's see here. Split on a comma or other substring. So here there is a split method. Okay, that is built into strings. Okay, but strings a variable. So strings that split. ABC. Okay, no, that's the string, and we're splitting it by this method. So this is so they're basically we're using strings. Now is that a library that we have to import? No, it doesn't, because it's well, let's try it out. Okay, so I'm gonna get rid of this for a moment because I don't need that at the moment. Okay, and what I want to do is do this. First we'll say S. Use a walrus operator to dynamically, not have to type it and do all that stuff. Okay, S equals. Okay, and we're gonna do strings dot split, and again uppercase, because any exported methods. Now the reason why that concerns me is because that implies that it's an exported method, which means it must be coming from something else. It makes me want to do this to. So that implies to me that I need to import strings. But before I try that, I'm going to try it without. See if that's actually what I need to do. Strings.split. And what I want to do is say, hello, how are you? Okay, and we are going to split it by a space. Okay, and then I want to fmt dot print line, and I want to print s. And let's see if it lets me do that. Okay, so let me go to the Go terminal. Let's run the file. Okay, undefined string. So see, that tells me that yes, I need to import it because it's undefined, meaning I never defined it. That makes sense to me. So I need to import that module strings. Okay, so that should make that available. And it works. See, we see the square brackets. Hello, how are you? So in that case, if that is the case, I should be able to do 1 and I should get how. Okay, that should be the second item in the array. So let's just confirm that. Good. Okay, so that's how you would split a string. So I would take the string using, so I have to import strings. So I need the strings module from the standard library, and that's going to give me these methods. So I'm assuming that there's also going to be a join method. So let's find out. Let's do this. So I'll just do strings dot join. If not, we'll look it up. Dot join. I assume that's going to follow the same pattern. So I'd give it the string, which is, or the array, which is s, and then we would say how we want to join it. And we're going to say a space. Theoretically, I'm assuming, again, I'm making this assumption that if that's how you split a string, should be how you join a string, and that should be probably capitalized. Okay, so let's see if I'm right. Yeah, and that works. Okay, so in that case, that was pretty straightforward. Okay, so that's how you would split. This would turn it into an array based on this character. So if you've done this in JavaScript or Python, you're probably very familiar with this pattern. Okay, very useful thing to do when you're trying to like parse a string. And then, okay, now I want to reverse it. So now as far as how to reverse the string, my first thing that I want to reach for is see, hey, is there a way for me to reverse a slice or an array? Okay, because again, slices are really kind of like the more manipulatable version of an array that we can work with in Go. Again, it's just kind of a weird fantasy subset of an array, which is why it's called a slice. So I'm going to look up, hey, can I reverse a slice in Golang? Okay. If not, there's other ways of doing it. We can do always like a reverse loop. Okay, but let's just see here. Do they have is there a method? Okay. Let's see here. There is not a built-in function in the standard library for reversing slice. Okay, so then we have to use a for loop. Okay. So then theoretically, if I wanted to reverse the string, what would I have to do is do a for loop, which we haven't done. We haven't really talked about that yet. So I'm going to save that for later. But now we know there's no, I would just have to do a manual, or I could do like a recursive function that recursively like loops works its way backwards into the array. Okay. But in that case, I would need to figure out what the, again, we haven't done the arrays and collections yet, so I'm not going to get into finding an array's length. But we now know how to split this into an array of strings, and then how to join those strings back together. And again, if we want to do further operations, we would kind of have to generate some of our own functions. But what other methods does this strings library provide us? So let's check. So I would say like go library strings. Okay, strings package. Here we go. Is this the one I'm thinking of? Yes, strings, and it's part of the standard library. Okay, so see we have all these methods available to us in strings. Okay, so split after, replace all. Okay, that's probably going to be pretty useful for like replacing chunks of a string. Repeat, map. Okay, so you can use map to like alter each letter in a certain way. That's cool. Just trying to see if there's anyone that really kind of jumps out at me. Trim is just going to trim white space. That's generally how it is in most languages. Okay, these will change to upper to lowercase. Assuming title just uppercase is the first letter. Repeat, replace, split. Okay, there's split method. We just used that. Okay, this will tell you the index of where a substring is. That's good to know. And this is generally like, and again, the reason why I'm going through these motions of one is also for you to see like how do you learn more? Like once I learned a little piece, like in this case, like I learned that I need to pull in this strings library to get the split function. Probably a good idea is for me to go look up that library in the standard library and just see what else it offers, just so that way I'm aware of what it has. Okay, so count like how many letters on the string, whether it contains a substring, whether you want to compare two strings, see if they're equal. So that's all fun and good. Okay, on that note, let's also look up strconv, string conversion. Okay, see what that, because we've used that before too. Okay, and yes, so it's just like, you know, to an integer, to into a string. Okay, so it's like into to integer. Parse bool, parse. Okay, so this is parsing things from a string. So all of this has got to be done with strconv. Okay, and that's pretty much it. Okay. So good to know. Those two libraries are available to us in the Go standard library. Okay, so I think that gives you an idea of like where to look as a starting place for like when you want to do something with strings. But basically what it comes down to is like a lot of this stuff you'd have to kind of build your own functionality using loops, but there is a lot of the basic stuff there, but things like reversing, you'll have to kind of do it step by step. Okay, which we will do when we get to like loops and arrays more holistically. Okay, so let's go to Rust. Okay, so I'm going to move over to the Rust file, switch over to the Rust terminal, and I'm just going to do a clear to clean this terminal up. And again, the first thing I want to do is how do I split a string? So how to split a string in Rust. Okay, I did look at this up the other day. Okay, so there is a function. There's a method of strings that is split that you can use. So that's pretty straightforward. Okay, and that'll split it into a vector. Or actually, yeah, it gives you an iterator. So this is a weird thing about like the way Rust works. I remember running into this a few days ago when I was doing a coding challenge in Rust. Okay. There's a lot of things that are not necessarily as intuitive as you'd like them to be in Rust. Once you kind of are aware of them, it's not so bad, and actually it provides you with some new ways of doing things that are actually not bad. But basically what happens is that a lot of times, instead of like arrays and vectors and all these different types being iterable pieces of data, there's like a separate thing called an iterator, and almost all these other things can convert into that. And then that iterator has like all these iterable methods, like map and all that stuff. So essentially what we're saying here is that split will create the iterable object from the string, and then collect is a method you can use on iterables to turn them into something else. So what you do here, so if you see what we're doing here, see they type it. So this collect function will turn it into a vector of strings because that's what the type says. Whatever the type of the destination variable is, this will somehow, because again I haven't gone to too deep into generics in Rust, it will somehow like know like, hey, that's what the output needs to be, so I'm going to convert it into that. And that's what collect does. Okay, so let's try to split a string. Okay, so let me just kind of clean this out here in Rust. So let's see here, let's just say let string, or let's let s, which is going to be a string, equal hello world. Okay, and then we're going to say let ss, this is going to be the split string. Okay, and right now I'm just going to type it as a vector. Oh, you still have to say what's inside the vector. So let's say a vector of strings. Well, it has to be pointers to strings. Okay. So that just means like it's a vector of string pointers. So technically, what it's going to do, it's going to end up iterating all of those things and turning them into a pointer to the string, instead of actually like copying the string. Okay, so I say equal s, that's hello world, and I'm going to split it. and then we'll split it by a space, and then I'm going to use .collect to say, hey, take the iterable that came out of this split method and turn it into the type of this destination type variable. Okay, in this case, a vector, which we haven't talked too much about. A vector is essentially just like more like the thing, kind of like a slice and go. It's the thing that's going to be a little bit more pliable and flexible in most situations, similar to like a Python list or a JavaScript array. It's just a lot more flexible because in lower level compiled languages, arrays are more fixed and less something you can work with. So we'll be doing a whole day on vectors at some point. Okay, and probably the next video, I think. Split. So let's just see if that worked. So then we want to print it. Print. Okay, print line. And then we use a Lisa thing, because technically we have an array of or a vector of strings. So it's something a little bit more complicated. So I need to use that : question mark to like unpack a more complicated thing to be like visible and printable. And then I want to print SS. And let's just see, does this work? Rust C, Rust run RS. Okay, let's see what our errors say. Expected string. Okay, so see, it wants a string, but what it really wants, what the variable really wants to hold is a pointer to the string. So what I need to do is actually change the variable type, because when I say, hey, this equals this is a string, but what I can store is the pointer. I need to store the address to where this string exists, because I'm storing an array, and all an array is a pointer to a particular spot in memory where that array begins. So this array of cars is really a pointer. That's essentially what that's kind of getting at. Okay, the second error is the size for value of type string cannot be known at compilation time. Okay. Okay, so the thing is, it doesn't know what the size is at compile time. That might go away now that it can determine that this is what's going to be inside of it. That's what's being split. So it is kind of set. Let's see here. Does it figure it out? Yep, and that still works. And the reason why that works now is because this is set. It knows that this is what S will equal. So it knows exactly how much space is going to end up being needed for this variable. So it knows exactly, because an array, depending on how many items it needs more or less memory. Same thing with a vector. So you need to kind of know things at a certain point to be able to allocate the memory necessary. Okay, so in this case, that worked out. But yeah, so there we split the string. Okay, and as far as joining it, is there a join method? Let's see here. I don't think join a vector to a string in Rust. I don't think that was quite as easy or straightforward. Okay, later, so after 1.3, join is available. So let's see here, string list as a vector, yep. Okay, so technically, yes, that does exist. So let's see here. So let's say let SSS, which will be, we'll say at a string, equal, okay, s dot join, but with no space. I think that should work, because again, there's no possibility of it being anything other than hello world without the space. And the compiler should be able to recognize that and know, okay, hey, I know exactly how much memory I need to allocate here. There's nothing that's like too dynamic. It's nothing that's like relying on user input or variables I don't know yet that make it not unable to kind of allocate the memory it needs. Okay, so that should join it, and then let's print it. So I'll just copy this print statement. Print SSSS. I don't think I really need this for that, because it's just a string, so I think I could just print it. Method not found in at string. Oh, because it's supposed to wait. Let me think about this. Oh, because I did S, and S is the string. So SS. Because SS is the vector. And it was a method on the vector of strings. Okay, expected at stir found struct string. Consider borrowing here at ss.join. Okay, so what it wants me to do is borrow. Say, it's telling me. This is again nice thing about how Rust works, where it actually will tell you like this is probably what you should do. Okay, found string and wants this, but you should be able to get that result if you do this. Okay, so that's telling me that technically what this collected it into was string objects, and these are, which technically a point, this ends up doing that. So that makes me ask some questions fundamentally, like, is there a string object underneath a string struct? Like, I don't know the exact like underbelly of like the string struct and how it relates to sort of the string scalar type. Cool. So let's see here. So that tells me, again, we're going to just take its suggestion, see if the suggestion works. So in this case, I'm saying I'm going to say the address of the array. Okay. And that works. That works. And see, that's, again, one of the reasons why I think like, as much as I find Rust a little bit more frustrating to write in, and there's a lot more going on, a lot more you have to learn, so a lot more upfront costs, like, they do give you the tools to get there. Like the documentation is really cool. I like how like the Rust documentation is like set up in a way to kind of see all the methods and what traits are implemented on what. It does take a while to get used to reading, but once you learn how to read it, like, it gets a lot easier. And learning how to read the output from the compiler is super, super helpful. Probably the most helpful compiler I can think of, or that I've experienced. And I've experienced, I think, most compilers. I've done Java, I've done C#, I've done C, I've done C++, with GCC. I've done Ballerina, which is also in a JVM language. I've done a couple other JVM languages. All the staples: Python, JavaScript, Ruby, PHP. Even played with some Perl. But no interpreter or compiler has given me better error output than Rust. As frustrated as I get with Rust sometimes, the compiler is like, no, I got you, Alex. This is the problem. You just listen to me. It's always right. Generally, like, when I disagree with it, I'm wrong. So, okay, so we see that, like, so again, the logic is, again, you have to split it. That turns it into an iterable object. And again, that iterable object, okay, so let's see here, like, let's see here, Rust split method. Let's see if I can find the documentation on that. Here we go, string, is this the split method? String from, where, split. Well, first we wanted to do split. This is a string struct. Okay. Where did I search? Rust split method. Here we go, stir. That's where we saw the split method. And let's see here, we can find, there's split. Okay. The method split. Okay. And see, like, this is what, like, again, this takes a while to get used to, but the way this, like, Rust documentation reads, I can see, like, this is from the standard library, the string portion, or the stir part of, and this is the method split. Okay, and then I can kind of read, like, this is sort of like the implementation of it. There's different implementations, and this particular method exists within these traits. So essentially, anything that implements these traits, and we haven't learned about traits yet, but think of it, traits as like bundles of possible functionality that a particular object can have. Okay, so anything that has these traits can then use this method. Okay, so the method will look the same. So it's really annoying when you're actually coding it out, because essentially to implement a trait, you actually have to make all those functions for that thing on your own. But then what happens when you start taking advantage of the traits that already exist, and basically what happens is that, like, as a developer, if I know, hey, your object, this object in my library implements the clone trait, the debug trait, iterator trait, once I get familiar with the methods in that trait, it doesn't matter what your object is, I know exactly what I can do with it. because those methods essentially do the same thing because they all have the same signature. And this is kind of where like as you get more familiar with Rust, that you start really seeing some like benefits because people can create all sorts of custom objects, but I can quickly kind of get acclimated with them if they take advantage of sort of like a lot of these standard traits and implementing them. Okay, and basically it's kind of a neat way of doing composition. It's a very Go uses composition as well, and again we'll get to that when we get to like interfaces and whatnot. But the way Rust does it is a little bit more extreme. But I like both. I do prefer composition over inheritance. But yeah, so let's go back to split. So split. Okay, so what this is telling me, like, just go back to the method. Okay, returns remainder of the splitted string. Okay. Strings. So let's see here, split. Okay, and then we get this iterator. That's why we see this .next method. Okay. Just want to see where the exact return value is. Tell me like it doesn't return. So see this little arrow here, that means the return value. So returns the point of view, and then I'm not sure what this asterisk a equals. That might represent an iterator. So maybe like an iterator of a string iterator, but here's like that trait implementation for iterator. So this type of elements being iterated over. Functions, for something to be an iterator, it has to have like an item, next, all these kind of things built into it. So that's interesting. Again, it takes a while to, and I'm still getting used to like looking at this and it making quite sense. Again, it's categorized nicely, but there's a learning curve. But once you kind of get used to working through like these documentations of these libraries and custom libraries and how they're all kind of set up in this way that's organized by like traits and the implementation of those traits, you can move very quickly. Even though it's such a low level language, you can pick up things pretty quickly because everything kind of there's a sense to it. There's a sort of a path, but it's very different than any other language. And that's always like the tricky part with Rust. But at least we know how to split and join a string. Okay, now then the question becomes reversing. Can I reverse a string? Yes. Because I did do this the other day. So how to reverse an iterator in Rust. Okay. I think there was, yeah, it looks like there is a method. So I think let's try to see if we can do this .rev method. Okay. So that would be on the iterator. So I would do the .reverse first. So .reverse. Okay, and basically I say I create the iterator by splitting it. I reverse the iterator, and then I'm going to collect that iterator into a vector. And so let's see if this does what I think it's going to do, which I should get world hello. No, I get an error. So let's find out what it says. Okay, the method collects exists for struct, but straight bounds were not satisfied. Called on first due to unsatisfied trait boundary. The following trait bounds were not satisfied. Split. Reverse iterator. Okay, which is required by app mute. So let's do this. Okay, so in this case, here they're using a vector. So they're using a vector and they're turning into an iterator, and then they're looping over the reverse version of that iterator. So in that case, let me do this. I am going to collect it, and then I'm going to take that vector, turn it into an iterable from the vector, reverse the iterable, then collect it, which I don't think that's going to do what I want it to do, .join. Yeah, let's give it a shot. Okay, didn't quite like that either. Okay, so let's see where Cannot infer type of type parameter B yet because this is not the right type for that. So technically what I would need to do is do another one of these. Vec and stir, because I need to save the new vector. So I need to get rid of the join here. And then I can go over here and just say, hey, this is sss.join is what this is going to be. Okay, because I want to be joining the vector. Okay, let's see if that gives me what I want. Oh, doesn't like that either. Let's see why. Expected struct vec found reference. Okay, so now we'll see the suggestion. Now it wants me to remove the borrow because I don't need the borrow anymore. And it knows that. I still don't feel like 100% sure why that's the case, but the compiler knows, and the compiler is kind and generous and gives me that hint. Okay, even though it still doesn't work. Okay. The reference of a reference, fun. Value type vector cannot be built from standard iterator item add stir. Okay. Let me think about that. Okay. I just did this the other day. Reverse. Iterator implements rev or self. Okay. First iterating over a vec. I just want to reverse it. Or if you want to call iterator methods such as reverse iterator only into iterator. So it's equivalent to, this is just basic precedence. .iter.rev, yeah, I get all that. Okay. Turning iterator back into a vector Rust. Okay, so let's see here. Let's not get into unwrapping things. How to return a vector strings in Rust. Let's see here. Lines, the white space, like yep, this is kind of what we already did. There's a guide. Oh, here we go. A guide. Let's take a look. Let's take a look. Rust iterator is a guide. By the time you walk out of here, you should understand what an iterator is good, what you will learn. Okay, let me just find, I'll give us a deep read after the fact, but just want to find the answer I need right now. Looping, iterator, iter. Okay, iter, the method is defined directly in the type. This method will borrow the data immutably and return an iterator that provides immutable references. Okay. Itermute is defined directly in the type. This will borrow the data mutably and return an iterator that provides mutable references. Okay. The implicit call, okay, into iter. So, iter. You see what the difference with into iter is? Trace implemented the type, which gives us the iterator. This one consumes the data and wraps it in an owning iterator. If all you could do with iterators was loop over them, with the for keyword they wouldn't be all that useful, but there is a plethora of adapters that transform the iterator into other kinds of behavior. Okay, I get that, Okay. This is for filtering. We're going to definitely be doing a video about mapping and filtering. So there's a hint, there's like a little preview. you're going to have to turn into an iterator to map, then filter. Collecting, we all know how to turn a collection into an iterator. How do we turn an iterator into a collection? Like provide an iterator tray. We could try to convert from a vector to an iterator and back. So let's see here. Into iterable. Okay, fact into iter, fact iter to dot collect. This is how we produce an error. Type annotation needed. Yeah, because you have to tell it what you're collecting to. It doesn't know what we're trying to collect into. Return type, let us know what concrete type we want to collect. Okay. We could use the turbo fish syntax. Okay. Back. Okay. Got it. Ooh, that's a nice trick. So here we can actually just say, hey, when we use the collect method, you figure out what's supposed to belong inside the vector. Just know it's a vector. So let's try that. Okay, see if that makes our lives a little bit easier. Okay. That'd be cool on vec at stir. Okay, so that's interesting. We're getting a ref. So basically, what that is turning into is a reference, a pointer to a pointer of a string. Gotcha. See if I do something like that. I put that back in there again. I'm gonna get that previous error. Borrow. Yeah, let's just print the thing. See what we got back. Okay, so there we have the array reverse, which we do, and I want to join that array. And what happens if I just print the address, if I put this? Okay, and then if I put two of them, what happens? So let's see here. What if I do dot join here? Okay, can I be called join? Okay, let's see here. How can we join this type? What if I do this? We do this again, and let's see what if that changes anything. Okay, that doesn't. So we need to figure out how can I get this into something I can join. How to join in Rust. Join them into a single string. We did that already. Let's just change the order of this search. How to join that in Rust. What if I do this? At stir again. What do I get? Go from stir I see, because that's a reference and that's a reference. So what if I take the off the reference here? I just do, maybe try that. Let's see what that does. Yep, but you still end up in the same place. Okay, let me actually refer to my previous code. Let's see here. How did I do this before? Okay, so let's go to git.generalassembly.com. Nope, not wrong. github.com. And what I want to do is look at my daily code practice repo. Let's go take a look at my Rust folder. Rust. Coding challenges, reverse strings. This is where we have to figure that out. So let's see here. Let's see, I did everything from a string from the beginning, not from like a string scalar type. Okay, so what I did here is I split, and then I turned each one into a string, and then I collected it into a vector of strings. That was the first thing I did. And then I did is we created a mutable reverse vector of those strings. And then what I did is I then looped over it and then inserted those things backwards into a new vector, and then I was able to join it. So this is technically what I should do. I was hoping I could do it in a more straightforward way, but it doesn't necessarily want to do that. Okay, so let's try this one out. So again, we take the scalar string, because again, this function was receiving like a pointer to a string. And for those of you who aren't familiar with pointers, they're just instead of storing the actual like letter or the collection of letters in a place, what you're doing is in the variable you're storing the location of where the location is. It's kind of like, instead of, let's say I have a bucket, in that bucket, instead of there being a pie, there's the address to where the pie is. And anytime you need that pie, you can just reach in that box, get that address, and then walk over to that address and get the pie. But you don't have the pie in the box. That's essentially what a pointer is. So you're getting a pointer to a string, and basically what I did is I split that string, which again gives you back the iterator. Then I can map over the iterator because iterators are mappable, and then collected the results of that into a vector of strings. Okay, so I'll leave it at that. Like here, you can kind of see the syntax there, and you can see where you can find it. You can find that on my daily code practice repo. Just head over to github.com/AlexMercedCoder. But as you can see, things are generally going to be a little trickier in Rust. Although I am sort of, yeah, it looks like you just kind of have to go into strings to do what we want to do. So let's just do that. Okay, so in this case, what I want is a vector of strings. So then what I need to do is then map. So we'll learn a little bit about map ahead of time in Rust. So I'm going to say for each token, so for each thing that's in there in the iterator after I split it, what I want to do is say s.toString. Okay, let me just make sure that's the way I did that. Yep, s.toString. Okay, and then we collected those. Okay, and then I was able to take the string, and then let's see here. Well, let's just still see if I can split the string ss.toIter.reverse.collect. Let's just see if that still works. Okay, like if I just switch this over to strings, can I just do what I was trying to do before? Okay. Value of type vec string cannot be built from item at string. Okay. And this is on. So the first line was successful. But again, we built a iterable. what if I change this to a pointer? Does that have any benefit to us? Yeah, no, it doesn't like me borrowing. Okay. Okay, let me run that. Like, where did we run into the problem? Looks like it was the issue was with collect. Okay. So what I could probably do is do a vector of @string. How does does it let me do that? Not found in @stir. It works. Stop map. Let me just see here. Stir dot split. 2 underscore. Oh, I did that wrong. It's camel case in Rust. 2 string. I mean, snake case is the standard in Rust, and they actually enforce that. You will get errors if you name things wrong. Okay, cool. At least we're getting it now. I am receiving the vector now. Question is the join method implemented on a vector that is a vector of string pointers, not a vector of string objects? So let's hope for the best. Dot join. Okay. Can I do it? Will you let me do it? No. It doesn't like it. Let's see here. Can I convert vec string or @string to vec string? Is this a thing I can do? I want to do it the other way around. Anyone else wants to do it the other way around? Convert to Rust. How about this? How to convert string or a pointer to a string to a string. Okay, yeah, that's we used that earlier. Okay, so this might be what we want to do to an own string. Because again, here we're just getting, this just gives you the pointer to the original string, which is not necessarily mutable and kind of exists somewhere. So maybe we got, like, it's basically to own, it's kind of giving us our own sort of string that we can kind of play with a little bit more. And maybe I can then do this. Let's see here. Just a little bit. Is that a thing? Okay. @string to owned. Let me just do this. Let's see here. If I do that, what am I getting? String. Not call. Let's see here. Can I at least find? Will it show me if there's any methods that are implemented on this particular type? Okay, yeah, no one's really dealing with pointers to a string. Good times. Okay, yeah, so I guess the way I'd have to do it is I'd have to do a loop. Really just trying to avoid doing loops and conditionals at this point, but that would be the way I had it in my code before. Would be sort of like, it seems like to be the way to do it. I mean, unless it lets me, let's see here, let me just see if it, like, so let's say if I just did this and just reversed it, not collected it, I think that should still just print me out hello world. Token. Oh, need a semicolon. Let's see here. Reverse iter. Iterable. Hello world. Yeah, that's something to play with. I'll explain that a little more. There's gotta be an easier way. I know of a way. I don't like that way, but again, Rust don't. The first time you do things in Rust, they don't make it easy on you. Okay, but that as you can see, like again, Go is definitely the more developer friendly language, but I do love the errors in Rust. So I'll see you guys all in the next one. Have a great one. Ciao.